All right, so today we are talking about conditional statements. This is similar to what we were talking about previously with the conjunctions and the disjunctions, only this time instead of an and or an or, our statements are connected in the pattern of if and then. So if P, then Q. The symbol for this is a little arrow. So when you see the little arrow, it is saying if P, then Q. The two portions of the sentence are titled the hypothesis and the conclusion. So the hypothesis comes after the word it, and the conclusion is the result of that hypothesis. So if we're looking at an example, if they want us to identify the two parts of the sentence, we're just going to read through it, look for the key word if, and that'll tell us where our hypothesis is. So if the forecast is rain, then I will take an umbrella. The hypothesis comes after it. The conclusion is the rest. All right, so for this next one, we want to be careful, right? Because the word if is not at the beginning. So what they're doing here is showing you that you can rearrange the sentence. However, the hypothesis is always the part that comes after the word if. So if its last digit is 0, then a number is divisible by 10. So this would be our conclusion. All right, there's a couple more examples for you to try. Example 2, we're going to take a sentence that is not written as a conditional and rephrase it so that we do have a conditional. So if a mammal is warm-blooded, or basically we want to take a mammal is a warm-blooded animal and rewrite it into if-then form. So usually what we'll want to do is take the first part of the sentence as the if, and then the second part as the then. So we may need to rearrange some of the words. We may need to add in some extra words. We just want to make it so that the sentence makes sense when you read it out. So if an animal is a mammal, then it is warm-blooded. So again, we made the mammal portion our hypothesis, and the rest we made our conclusion. Okay, for the second one. If a prism has bases that are regular polygons, then it is a regular prism. All right. All right, so for example 3, we're going to go through and try to determine whether the statements are true and false. This can be tricky because it's not as straightforward as it was with conjunctions and disjunctions. The phrase we want to remember here only false if broken promise. So what does that mean? So we want to think of the conditional statements as promises, right? So if the first part is true, I promise you that second part is true. However, if the first part is true and the second part turns out to not work, turns out to be false, then I've broken my promise and we have a false statement. If, on the other hand, the first part of the sentence was completely false, then it doesn't matter what the rest is, because I wasn't starting with an accurate promise. Or another way to think of it is, if the first part of the promise is false, then it doesn't really matter what's happening with the rest, because we're starting on, false ground. So, if you divide an integer by another integer, the result is also an integer. Well, let's test that out. First of all, we need to remember that integer means whole number, right? So no fractions, no decimals. So if I divide two numbers that don't have fractions or decimals, do I get another one of the same type? This can be true, right? So if I take 4 divided by 2, it gives me 2. But unless it's always true, it's not going to work. So what happens if I take 5 divided by 2? Notice I get the 2.5. So, since it did not work all the time, the sentence is false. Right? I promised you that if you divided two whole numbers, you'd get another one, and we didn't. This is what is called a counter example. Anything that proves a statement false is your counter example. So for the next one, if the next month is August, then it is July. So if it's August next month, I promise you it's July right now. Is that true? Yes. Right? July always comes after August on the calendar, so this will always be true. Here's the tricky one. If a triangle has 4 sides, then it is concave. Well, does a triangle ever have 4 sides? No. So if I am starting off with a false promise, it doesn't matter what happens the rest of the way. We cannot mark this as false, right? I can't break a promise if we never started off on the right foot. Unfortunately, since I only have true and false as answers, I have to say this is true because the hypothesis was false. Again, if the hypothesis is false, you can skip the rest of it. Just put that the sentence was true and move on from there. Alright, so the last thing to talk about today are related conditionals. So we've got a converse, inverse, and contrapositive. Notice in the table, basically all we're doing is rearranging the P and Q and adding in the negations wherever we need to. So if we're given a sentence, we first need to write it as a conditional. And like we said, we may need to rearrange some stuff. So if a cat is a lion, then it can roar. Is that true? Yes. Lions can roar. Okay, the next thing, we have the converse. So all we're going to do now is reverse the order. So, if a cat can roar, then it is a lion. Is that always true? No. Right? If we can think of anything that can roar that is not a lion, then the statement is false. So a tiger is a cat that is not a lion. Alright, so then we have the inverse, which means we're just going to take the original sentence and negate it. So the cat is not a lion. Then it cannot roar. Is that true? Nope. Because again, a tiger is not a lion, but a tiger can roar. So again, any example that makes it false, you got to put a false. And finally, we have contrapositive. This is where we flip the order and negate it. So, if a cat cannot roar, then it is not a lion. So is that true? Well, yes, because all lions have to be able to roar, generally speaking. So if it can't roar, it's not a lion. So we'll notice the pattern. The conditional and the contrapositive should always match. The inverse and the converse should always match. All right, that's all for today. I will see you next time.